Welcome, ladies and gentlemen, to our tempo class tonight. We have Russell Hoffman of Evaton Technologies, a Eurorack maker, amongst other things, who's here to do some class for us. So without further ado, take it away.
All right. Well, greetings, folks. As Mike mentioned, my name's Russ. I live in Pittsburgh, Pennsylvania. I see a couple fellow Pittsburghers on the show here this evening. Yeah, I run Evaton Technologies, T-shirt here, making Eurorack modules. It's not my day job. It's something I kind of do for fun. I don't have any real structure for this evening because I kind of wanted to tailor this a little bit to what people's interests are. I mean, I can kind of give a little intro and bring up a couple of points here, but if there's at any point you guys say, oh, that's really interesting, talk more about that or not, feel free to jump in. But just a quick history of Evaton Technologies. I started doing Eurorack stuff probably 7 or 8 years ago now. It's been a while. And the first Eurorack module that I designed is the RF Nomad, which is a voltage-controlled shortwave radio receiver. And it's been pretty popular. Essentially, what it is a shortwave radio in a Eurorack module. And you have voltage control over the tuning knob. So if you can imagine taking a little desktop shortwave radio and twisting the knob, and you can kind of get those sort of weird sounds as you tune in and out, sometimes even between stations, or as you tune past stations, you get kind of those sort of little squelchy sounds. That was the idea, was to make a module that would automate that. And at the time, I was doing circuit board design, sort of freelance as a contractor, and I was working for a large ham radio equipment manufacturer. And so it was just kind of, I had some conversations with a friend of mine who used to live here in Pittsburgh. We would get together and, just kind of nerd out over, about synths over lunch. And we, got to talking about this whole idea of, a shortwave receiver. And, remember when you were a kid and you played with the shortwave receiver and you made these really goofy sounds, it's like, wouldn't it be cool if you could make a module that did something like that? And, it was just kind of all the elements came together because, here I am, a guy who's interested in synths, and I happen to be working for, doing a lot of work for a radio company. So I had a bunch of radio circuits in my head, and I was like, you know what? I know exactly how to make that module. And so, I sat down and designed the thing, and it kind of took off from there. I don't have a ton of modules in my lineup. I can show you all of them. But I kind of do things that are sort of interesting to me. So, there aren't any huge blockbuster modules like, mutable instruments, braids, or something like that, but I do things that they're fun for me. So, with that said, my background is, I'm a Eurorack manufacturer. I'm just a guy who builds stuff in his basement. Okay.
Just like almost every other Eurorack manufacturer.
and that's the truth. I mean, there are exceptions. Make Noise has their own building. I've been to it down in Asheville, and they're doing very well. There are a couple of the bigger manufacturers here in Pittsburgh. Of course, they tell me there's some other modular synth company in Pittsburgh called, Pittsburgh Modular or something like that. And I guess they make a bunch of stuff. I don't know anything about it. I'm kidding. It's a good joke. Anyway. But yeah, for the most part, most of the Eurorack people are one or two people working, in their garage or basement or whatever, and just because it's fun. And the nice thing is then there's a real community around it. Whenever I go to a couple of big shows or NobCon, there's some stuff. I've been to NAMM once. go to Mutech up in Canada, and whenever like the Eurorack manufacturers get together, it's it's not like a bunch of big people from like Yamaha or Korg, and trade secrets, and it's a community. We all just kind of like get together, eat pizza, and drink beer. I mean, so it's a good gig. Anyway, I'm rambling. So for those of you that maybe aren't into modular synthesis, the whole sort of the whole point to the thing is that you can take all the building blocks of synthesis and take them individually and combine them in any way you want. And let me just switch over here. Yeah. So, so what I got over here on the right-hand side of the screen is a picture of my modular synth. And each of these blocks, just move over here. Like each of these individual little blocks is a module. And they, individually they look like this. So you got just kind of a metal faceplate and some kind of circuit board behind the faceplate. And sometimes, the circuit board sticks out perpendicular like this, or, other times it's kind of parallel. But what makes this system modular is that these are interchangeable. And kind of the original modular synthesizer that you think of is the Moog Modular, which was a bigger format than Eurorack. Eurorack's very common right now, but the Moog format modules were larger, and they actually had like a plug-in backplane, and you literally would unscrew these things and pull them out or plug them in. They made that sound too, but that kind of put some constraints on the sizes of things. They have to be sort of fixed multiples of widths and things to fit into that format. And so, what Eurorack does is it standardizes more or less the input and output voltages and the power supply for the thing, and you can have varying widths of modules, and they're measured in what they're called horizontal pitch. If you've ever heard of HP, that's what this stands for, is horizontal pitch. And so these things can be different widths. Oh, there we go. But they're different multiples of widths, and so they'll fit side by side in the case and stack up neatly. So, as you see, these things all fit in here, and there are no gaps between them. And then the power for them is defined. So you have this power cable, which is a standard pinout. There's minus 12 volts on one end, a couple of rows of ground in the middle, and plus 12 volts on the upper end. And then there's some optional pins for 5 volts and some other things. And anyway, the whole point of that is that because it's a defined standard, anybody who follows that standard can make a module that will plug into the system and will play well with other modules. And what makes all that possible is the fact that these things use voltage control. And so just to kind of demonstrate that, I have my oscilloscope up in the upper left-hand corner here. And what this is showing is just a sort of a strip chart. And you can kind of sort of see the noise kind of rolling by there. But all of these modules either generate a control voltage, use a control voltage, or generate some kind of audio that is somehow shaped by a control voltage. So like, for example, I have this gold module, and I can just output just a steady state voltage with it. So as I'm turning this knob, I'm just changing the output voltage, right? Okay. So, and you can see what the scope's doing, right? As I change the voltage, you can watch as time goes by, you see the trace. So, so what I'm doing here, this is a voltage controlled oscillator, and I'm just taking the sine wave output of that and running it into my mixer, which is going to go into the audio. And if I turn up the level of this, you should hear a tone. Okay. Everybody hear that okay? Okay, good. And the frequency of this oscillator, I can set it manually with the tuning knob. Okay, I can even change. Let's see. All right. If I take my control voltage out of this guy that I'm looking at on my scope, I plug that into this CV, it changes pitch, and now I can control, and you can see the voltage is directly controlling that pitch. Okay, not that exciting yet, but you get the idea here. So one of the other things that's defined as a standard in Eurorack and also in the 5U format, which you can see the 5U guy behind me, the oscillators are defined that a change of control voltage of 1 volt changes the output frequency by 1 octave. Okay, so for every time you increase the control voltage by 1 volt, you double the frequency. And this module here, I don't know if you guys seen this like tremendous lag. Sorry, my computer's an antique. Anyway, so this module is a Midi to CV generator. And so I don't know if you guys can see. Yeah. So I got this Korg Poly-800 just generating Midi data. And if we look on the scope, okay, so right now I've got the scope set so that each of the little white boxes is 1 volt per division vertically. So I play this D, I play the D above it. You can see that that was a change of 1 volt. I add 1 more volt, I go up another octave. 2 octave jump. Again, very, very basic, but what I'm doing is just, whatever voltage goes in changes that oscillator frequency. You can use the same principle to control other things, or for example, I want to take the output of this oscillator and run it into a filter. So if you look on the scope trace, I've got this sawtooth wave coming out of a low frequency oscillator. So I'm going to take that and I'm going to patch that into the cutoff frequency of the filter. So you can see the direct relationship between this voltage and that filter cutoff. And
Ladies and gentlemen, we now have FM.
indeed. Oops, excuse me. So those are that's the basics of modular synthesis, is the fact that you can patch these things together in various different interesting ways. What I can do is kind of show you some of the modules that I've designed and kind of show you why I did that. First one I'll show you, of course, is the RF Nomad, which is my shortwave receiver. Just patch that into the output here. You just kind of hear a little bit of noise coming out of that because it's a shortwave radio. You're kind of dependent on what's available. But the interesting thing is that this is noise, but it's not steady noise.
Russ, is that signal affecting the oscilloscope at all?
No, that's still just showing that LFO.
Okay.
So in fact, one of the things I can do though is I could patch that LFO into the tuning and show you what that does. So this is that LFO signal. I can patch this into CV in. So one of the problems with having a shortwave radio module like this is that you can't always be guaranteed to have a good signal. And so one of the things that I designed is a little transmitter module. So right now the transmitter module is just transmitting a steady carrier. Let me, if I turn off the CV input, so it's currently ignoring this LFO, I can tune this just to some steady part of the tone there. And now, as I bring up the CV, So again, right now, all you're hearing is just the carrier tone. If I get my iPhone out here, I can plug an audio signal into the transmitter. See if I can find something here. All right. So, transmitting some audio, receiving it on the Nomad. Crank up the CV.
Sounds like when you slip off frequency, you're picking up some harmonic of the carrier.
Yes, because it's actually a sideband receiver, so you get the carrier in there as well.
Mm-hmm.
And anyway, I do apologize. The transmitter that I have in here is an earlier prototype module. It's not not the final one. I had a guy who I need one today. I was like, fine, I'll rip one out of my cabinet and send it to him. So just for purposes of tonight, I threw in one of the older ones so I would have something in the slot. But you can see kind of what the idea is here. One of the interesting things too is if you take this guy and you're using it strictly just as a noise source, you can patch that through a VCA and hit it with an envelope generator, and now you've got a hi-hat that's different every time you hit it because it's not white noise, it's radio noise. So that's an interesting application of that. Anybody want to see that? I can patch that up pretty quick. Sure.
Go for it.
All right, so what I'm doing here, everybody hear me okay like that? All right. I'm just going to take this audio out of the RF Nomad and just unpatch a bunch of this stuff real quick. I'll take the audio out, run that into a VCA. Take the output of the VCA and maybe throw that into a filter. Take the output of the filter, run that to the audio out. So let's see here. Right, okay, and then I need to take an envelope generator and use that to control Actually, I'm going to run the envelope generator to my oscilloscope so you can see that. Run that into the CV for the envelope. And we'll trigger the envelope off of my Midi gate over here. So what I should see, if you look on the scope, when I hit the key on here, this will trigger the envelope, or it won't. Hang on. What's going on here? Oh, right. Helps to plug it into the right spot. Okay. So you can already hear it's a little bit hi-hatty. So what I'm going to do is we'll add some modulation to the CV input on this guy. That'll move the tuning around a little bit, and that'll help liven up the hi-hats. All right, so that's kind of repetitive because it's you can hear the LFO going up and down. So one of the things I did, I like things that are not so terribly predictable like that, and so I made this module called the Clx Module, which basically has two square wave oscillators. I can show you those. So if you look on the scope here, very nice square wave. The other output is another very nice square wave, maybe slightly different frequency. Okay, so this one's a fast square wave. This one's a slow square wave. But then I have an output down here that takes the two of those things and logically ands them together. And you get interesting patterns. And to kind of really demonstrate this, if I make one of these fast and the other slow, you can see what's going on here, right? If I go turn this guy down, basically one is gating the other. So, you know, you can see you get these little fast pulses, but only when the other square wave is high. When it's low, you just get low. But if you have them both pretty close in frequency, you get these kind of funky things going on. And if I take that and I use that to gate this hi-hat, So you get this sort of irregular rhythm. And you get the same thing, in addition to having the two of those signals ANDed together, I've got an output that's the logical exclusive OR of those two, which gives you a different rhythm, right? So where this is useful is if you're using this to like clock different things in your system. So I don't know if everybody's familiar with the Turing machine, but what this is a module that every time you clock it, you get a different sort of pseudo-random voltage out of it. So what I'm going to do is I'm going to take the CV in to this to the RF Nomad. Instead of using this LFO, let's use a random voltage. I'll clock the random voltage. So now you get this like weird polyrhythm thing going on, right? And that's what I love about this little module is because it's so simple. I mean, it's just two square wave LFOs, but when you have these logical combinations of the two things together, you get these interesting rhythms that are related. I mean, they don't fall anywhere on you know, like a 4/4 time grid, but they're related to each other. And you got, you know, all four of these outputs, and you can use those to drive other things in the system to tie it all together. Like, let's maybe drive filter cutoff. And maybe it's more interesting if I switch around what these things are controlling. So like right now, I just have the straight square wave controlling the filter cutoff, but maybe if I swap that with the thing that's controlling the gate, it might be more interesting. I would say that's more interesting.
That's cool.
Yeah, and what's neat is, okay, so now I've got, you know, let's kind of bring this back into the musical context, right? You know, I've been doing a lot of technical talk about this, but from a musical context, now I've got this cool little polyrhythmic thing that's just kind of going on in the background, and maybe I'll like improvise something else on top of this, right? And you know, I can go in and tweak things, you know, live. So, you know, maybe I want to change the amount that these things affect things in real time, just as a nice effect. And, you know, say I'm playing my piece and I'm maybe improvising, you know, something on top of this, maybe like on my Continuum or something like that. And, you know, now it's time for a change, right? I just twisted one of those knobs a tiny bit. This is a different polyrhythm completely. Maybe do a little more. And there's just this like whole world of experimentation in 2 knobs of, you know, some weird polyrhythmic patch. And as you can see, I have 2 of these in my system, and I've done some live stuff where I actually use both of those, and I've just got like just crazy stuff going on polyrhythmically in the background, and it, you know, has nothing to do with a 4/4 rhythm. So, you know, which I find kind of interesting because, you know, there's definitely room for, you know, sequencers and 4-on-the-floor rhythms and things like that. But, you know, sometimes you want something that's like outside of that box, right? You know, because that's, you know, it's a very square box, you know, it's, you know, 4/4. So you can do stuff like this and go really experimental and just do some crazy drones and things. And, you know, I'm not really set up for that, but I think you can imagine what that's like, right? All right, so that's the Clx module, and it's again something I made because I sort of just imagined it up and thought this would be a really cool way to do stuff, and it actually ended up doing a lot more than I thought it would do. All right, so let me move on to another module which I don't actually sell yet. A couple people have asked me about it. I just haven't gotten around to it. But this guy up in the upper left corner, let's turn this down. Is a CV source.
Can you point to it again?
Sure, it's this guy right here.
Okay.
Oh, gotta wait for my OBS to catch up to me, right?
Thanks.
Yeah. But this guy, these 2 little round things on here, one is an ultrasonic transmitter and the other is an ultrasonic receiver. And so what it does is it sends out an ultrasonic pulse, listens for an echo, and measures how long did that take. Well, that's sonar. You know, it's measuring distance. And so let me plug in my, I'll plug in my oscilloscope to the output of this guy. And you can see it's a little bit noisy there because, well, the surfaces in this room aren't necessarily all, you know, hard surfaces. But the general gist of it, take a nice flat surface here, my tablet. Gets a little smoother now, right? So it actually has a definitive reflective surface. I move it closer in. This control voltage goes up. As I pull it out carefully, control voltage goes down, right? Okay. So, and if you don't have a regular surface, like say a hand, it in general goes up as you get close, right? But it's, you know, it's not a regular surface, so it doesn't always get the first reflection, and it kind of jumps around, and it's kind of cool. If you use that to control, like say filter cutoff, for example. Yeah. I just patch something up here real quick. So what I'm doing here, I'm just going to patch up my pseudo-random voltage generator to control the pitch of an oscillator, so I have something akin to a sequence. Okay, and again, I've hooked the oscilloscope back up so I can see the sonar, but I've got it, you know, going into a mult here so I can see it on the scope and patch it into the filter cutoff. And so again, the Clx module is clocking my pseudo-random voltage generator. That's what's giving me the cool funky rhythm.
It's like somebody's playing it.
Exactly.
Hey, Russ, do you have a quantization module in there by any chance?
I don't have a quantizer in this system. Mostly because I don't want to buy one until I make one of my own. Because I have some ideas about that. Let's see. You can see I'm kind of hitting my, well, I guess you guys can't see what I'm doing here. I've got my, as I'm pulling this in and out from the module, it's affecting the cutoff. Anyway, I did a live performance a couple of years ago, and I have an electric ukulele, and I was running that into the modular and using the sonar module to again modulate cutoff just like I was doing. And I had some delays and stuff going on, which always makes things more fun. And the cool thing was that the surface of the body of the ukulele. Let me switch this back over here. Whoops, how about that one? The front flat surface of the ukulele is a nice regular surface, right? And so I could sit here and kind of jam out on the ukulele into the modular, and as I walked forward and away from the modular, the sonar module was like tracking basically my body position by bouncing it off the front of the uke, and I could use that as to like lean in for expression and stuff like that. It was really cool. So it was really fun. So there's that module, and then these two guys. Yeah, switch camera module again. These two guys here are special modules that interface with the Hoffman Continuum or the Hoffman Continuum Mini. Unfortunately, I can't demo those tonight because once again, I sold my last connection cable. So I can't like hook them up, but essentially what they do is on a Continuum or a Continuum Mini, I don't know if you guys are familiar with these. So this is the Hoffman Continuum Mini, and I also have the full-size one over there, which is not within the camera view, but I'm sure you guys have seen me play a little bit. You have three-dimensional control. So there's like an X direction. There's on the Mini, there's a very small amount of Y, kind of up and down. And then there's a Z direction, which is you push into the surface. I don't know if you can really see it. I'm actually pushing that down in there. There, you can kind of see. Anyway, what the Continuum, the micro CVC module does is takes those three motions and maps them to control voltages. So you can actually control three control voltages all at the same time with a motion of one finger. And the fact that I have two of these in my system, there's a little cable that goes behind the front panel. It's actually decoding a digital stream coming out of the instrument. But it'll actually track two fingers if you have two modules in your system. So a neat thing you can do is have the left right forward backward pressure into the surface mapped to like pitch left and right, say filter cutoff, for example, front to back, and the level of the VCA as the pressure into the surface. And you can actually, if you have two VCOs, two VCAs, and two filters, you have a two voice synth that you can control with two fingers. And the thing that I didn't mention in that patch is the envelope generator, because there isn't one. The Z-axis, that pressure that's controlling that VCA, your finger is the envelope generator, which is really cool because now you can get away from things like, if you've got a sequencer going and an envelope generator, just to control, sort of a normal, maybe like a TB303 type sound, where you get like that same envelope over and over again. Something like this, and gosh, I really wish I had that cable. I could show you, like you could hear what's going on, but you've got continuous expressive control over every note you play on a modular synth. And imagine, you've got all these different modules that can do all these crazy different things. You can map any of those XYZ motions to anything. And they don't really have to be pitch. I mean, like literally, you could be playing another instrument. I've got my Midi keyboard, Midi converter here. I could be playing the notes, with my right hand on the MIDI synth here, and that's doing MIDI to CV and controlling pitch and triggering envelopes or whatever. And this guy turns into a 3-axis CV controller for other things in my patch. Because like one of the things, about doing modular synth is these things are all knobs, right? And you want to affect, something in your patch, you turn a knob. Well, how many knobs can you turn at a time? I don't know about you, but I can only do 2 because I got, 2 opposable thumbs. I can turn 2 knobs at a time. Maybe you can get a joystick module that you can like control, 2 parameters at a time. But something like this with the dual micro CVC modules, you can control, with 2 fingers, 6 parameters at one time. It's a little tricky, but it's useful. Gosh, I wish I had the cable here. I could plug in and show you that. But maybe another time. Speaking of time, how are we doing?
You've got 4 hours left, Russ.
Okay. If I haven't like bored your ears off yet, I can certainly talk more.
Not at all.
Let me just pause for a moment, and that's kind of a bit of an overview, kind of bit of a focus on the sorts of things I'm interested in doing with modular. Anybody got any questions? Because I can talk about this for hours.
Does your scope have a spectrum analyzer in it? I see it looks like a digital scope.
Yeah, it does. In fact, I don't know how well it does on audio, but
yeah, same with mine.
I can try it. Because that's a nice thing to see is showing the frequency components of, like, say, a filter that is cutting things off.
Many people fail to understand from an audio perspective what's going on between a sine wave and a triangle and a sawtooth and a square wave.
There's a lot of math there, but if you guys can bear with me for a moment, I can see if I can get this thing to show the frequency spectrum analyzer on here. I don't know how well it does.
Yeah, because it's probably all the way into RF, so it'll be just on the far left side of the screen.
Yeah, but let me look. I mean, if I had thought of it, I'd have brought my other laptop up because there's a really good spectrum analysis program on it. If you guys want to take notes, there's a program called Baudline, Baudline, Baudline. The only system it doesn't run on is Windows because the author has a thing against Windows, and I can't really blame him for that. So you can run it on Linux, you can run it on OS 10, you cannot run it on Windows. But there's a really cool spectrum analyzer, and it's free, called Baudline. The support for it, like every now and again, the guy decides to do updates. So like, I don't know when the last time it was updated, but it's really, really powerful and good stuff. But anyway, let me see if I can get this going. I'll flip to the.
Is that at baudline.com?
Probably, yeah.
Yeah, it looks like it, yeah.
Yeah, I want to say the guy's French, and he does like DSP consulting work as his day job, and he like did this as a kind of a hobby tool. But it's an excellent tool. Let me see what I can do here.
As long as you're not Windows.
Correct.
Actually, a $25 Raspberry Pi, that would be a good application for that.
And I suspect it would run on a Raspberry Pi just fine.
Sure.
Yeah.
I think there are plenty of spectrum analyzers out there for Windows.
Oh, sure, yeah.
We're not hurting, but
it's a very good presentation, Russ. I'm learning a lot. Thanks a lot, brother.
Oh, good. I never know because people come from all different backgrounds, and I don't know if I'm talking over their heads, if I'm like being too simple. So, just, feel free to reach through the screen and knock me on the side of the head if you need me to adjust what I'm doing.
You're doing awesome. You're doing awesome.
All
So
right.
Russ, I accidentally ended up in a private chat with Morris, but I wondered if instead of having two square waves for that one module, if you had one of them pulse width modulatable, I think you could really get wild with that.
Well, what's interesting is you can actually use the module to sort of create pulse width modulation too, using the, I think the
Right. Well, I mean, that's
output
what you're
is-
doing, basically.
Right. Right. Yeah.
But
No, I get what you mean. Yeah. But let me see. Let me throw an audio signal at my scope and see if I can get spectrum analysis, because there's some really neat stuff I can show you with what filters do and so forth.
Oh yeah.
those naughty filters.
I think it's it's important if you look at a spectrum analyzer, it shows amplitude versus time, as opposed to like this right here where it's showing
Right.
voltage changes over time. So it shows it's amplitude versus frequency. So from left to right, you're getting from the lowest to the highest frequency, and up and down you're getting amplitude. So you'll see peaks. So if you just run a sine wave into it, you'll see a peak right at the frequency that the sine wave is oscillating at. But if you put in a square wave, you'll see lots of peaks, or a sawtooth or triangle wave. You'll see more peaks because there are harmonics being generated, and it's the harmonics that if you use a filter on a sine wave, what eventually happens is the sine wave just gets quieter and then it disappears. But with other waveforms, it starts cutting off those harmonics, which gives you that classic sound that you hear. Add resonance, and it's like adding another oscillator to the equation.
So here's something interesting, and I haven't even turned this into spectrum mode, but I'm still showing voltage versus time. It's just that I'm not doing the strip chart. I'm now doing this at real time. I know the focus is really terrible on this. That's just the webcam that I have. It doesn't do real well that close up, but you can see the horizontal axis. I don't know if you can read that, but it says that the time is 2 milliseconds per division. And so we've got 1, 2, 3, about 3.5 times 2 is like 6 and 7-ish. Anyway, milliseconds, period, from one peak to the next. And that tells me what the frequency of this triangle wave is, right? Because you take 1 over that and you get frequency. But the interesting thing, you see these little spikes that are showing up. Let me just zoom in there. Those are real. And that's just
trigger.
It's exactly what's happening there. Is typically this kind of a triangle wave oscillator is actually a sawtooth, but every other time out, it inverts the output and patches it back together. And so it doesn't happen instantaneously. And that's why you get that little blip there. And the interesting thing is that adds a little bit of harmonic content to the output. But let me see if I can, now that I've got the audio piped in here, I'm going to see if I can get a spectrum analysis of this guy. So you can't really see that. The selection that I'm picking here is called FFT, which is Fast Fourier Transform, which basically is doing some math analysis of what's going on the screen and saying, okay, rather than showing me the voltage over time, I want to show me instead the intensity of each frequency. So let me see what happens here.
Yeah, there you go. That's pretty clear, actually, even though it's just on the left side of the screen.
Yeah. So I may be able to do some magic here and get that a little better.
So while he's doing that, I'll talk about FFT, Fast Fourier Translation. It basically all sound is sine waves. So what it does is it takes a complex sine and breaks it, a complex wave, and breaks it down to the sine waves that make up that complex sound.
Okay, so this is kind of interesting.
I can explain it differently, but I don't want to nerd out here.
Sure.
Well,
I mean,
layman's terms.
there's a good bit of math involved here, but and what I wanted to show you was, well, if I look at a sine wave. So first of all, let me just point what's going on here on the screen. I'm gonna find something good to point with other than my finger. Drumstick. All right. So what the top view is the voltage versus time. So you can see that, very quickly in time, this is going up and down in a sine wave, and this is not a pure sine wave. You can see that just by looking at it. That's a pretty crappy looking sine wave. And on the purple here, what I'm showing, the y-axis is intensity. How loud is this? And on the y-axis is frequency. So this is showing a pretty strong and intense signal at what we call the fundamental. And then there's a good bit of sound energy here and here and here. This is like the fundamental frequency. This is double that frequency. This is triple that frequency. This is quadruple that frequency. Now, if this were a pure sine wave, what we would see is just one peak that says this sine wave has no harmonics. Let me see if I can't get a more pure sine wave. Good way to get a pure sine wave sometimes is to put a filter into self-oscillation. I'm not sure if I have any that do that real well, but I'll give it a real quick try.
Does everybody know about the harmonic series and sequence for this stuff?
Well, I certainly do.
Not really.
So while Russ is setting up, real quick, what you're doing in all of this is you're changing the language of translation. So amplitude measuring is one way, but that's using sort of XY plots with power and time. But if you change it to frequency, you're changing the basis. And the basis is sine functions instead of XY parameters. So you're changing the geometry to redescribe the physical phenomenon, and by doing that, you're putting frequency in the spotlight. Well, the solution to this wave equation is the Fourier series, which is a sum of sines where you're basically increasing the multiplier of the sine function, the thing that goes in the sine, which is doubling, tripling, quadrupling the sines period. And then the frequency, or the values for each of those multipliers is the spectrum. So the triangle there just had odd, if you look at this picture he has, the triangle wave had the odd values, the first, the third, the fifth, the seventh partial, high spikes, and the even ones were low. So if you just take basically the odd harmonics, the odd multipliers of that sine function inside the value of the parameter for the sine function, that's going to change the frequency, and the multiplier changes the amplitude of those relatively.
I think you probably lost 99.9% of the attendees already.
Well, you said it, but think of it, okay, in a piano key, if you hit low C, the next harmonic is the octave up. The next harmonic is basically a 3x multiplier of the sine function, which is the fifth on top of that as you start multiplying the frequencies out. And then they start to get weird, but you stay, the main ones that you're going to hear are just probably the first 4 or 5 partials. And
partials are harmonics.
They're harmonics, right, same term. Yeah. And to me, they're the multipliers of each of these sine functions that are the basis functions. So if you ever studied linear algebra and know about eigenfunctions, these are the eigenfunctions for the Fourier transformation.
So let me explain that in a way that
I can follow most of that.
So when you pluck a guitar string, you think you hear one note, but you're actually hearing like 4. And if you run your finger, if you lightly touch the string at certain positions along the guitar neck, you will hear those individual harmonics, or as he said, partials. Right? A lot of people use that for tuning, because if you go to the 5th fret and touch the 5th fret with your finger without muting the string or without pushing it down, you'll hear this real pure sine tone ring out. And you can use that, that pure sine tone plus doing the same thing on the string above it will allow you to hear just the pure sine wave without all those overtones, which mess your tuner up sometimes. So a timbre or a sound is made up of a primary harmonic, secondary, tertiary, and so on and so forth, going both up and down the spectrum. And that's what makes something sound like a guitar versus a piano, is the amplitude of all those individual harmonics.
Well, so the term spectrum is those values, the multipliers of all of those sine waves. That collection of multipliers is a spectrum, and that leads us to know that basically the pipe organ was the first synthesizer, because you're summing up sine waves at various, you pick the fifths, the odd partials, you're going to get a triangle wave out of it and so on like that. But that's additive synthesis, is the purest, closest thing to Fourier synthesis.
So all that being said, so I've got the closest thing I can approximate on my synth, which is I've got a Polyvox filter here that I've put. Let me just show you what I've got. So I've got this filter. I've cranked the resonance all the way up, and what happens on a lot of filters, not to get too technical, but the way resonance is implemented is that you're taking the output of the filter and feeding it back into itself, and that tends to emphasize the high frequencies. But once you get too much feedback, the thing turns into an oscillator. And the nice thing is that a lot of filters, just because of the way they're designed, when they go into soft oscillation, they actually get a fairly close to a sine wave output. And you can see that on the scope. The yellow trace there it's more sine-like than the one that I showed before. It's not perfect. And you can see the spectrum analysis. There aren't as many peaks beyond, so this is our fundamental frequency. There's some smaller peaks here, but they're a lot smaller than we saw before. And we can hear this. It's a fairly pure tone. Now, if I screw with the filter here, I can... There, and you can see visually you can see that's more sine-like, and you can see in the spectrum analysis, most of the energy is right there at that very first fundamental. Now, if I contrast that to, say, let's go with a sawtooth.
Lots more harmonics.
Loads of harmonics, and you can see them right there, and they're very linearly distributed. You can see they're very evenly spaced apart. They're multiples of each other, so you get a lot of energy that's a multiple of the frequency of the fundamental frequency. So the interesting thing to do now is let's run this through a filter. Okay, so I'm going to turn my resonance all the way down. I've got this is a low pass filter, and it should be reasonably obvious that it's
How many poles?
I think this one's 12. This is a Jupiter clone. So as I lower the cutoff frequency, you notice how I still have all of this stuff on the left-hand side. All this lower frequency content didn't really change, but all this higher frequency content stuff went away. And you can see now I've got not quite a pure sine wave, but a lot closer to it, and all that high frequency stuff went away. Now, let's see if I can really do this. If I crank up the resonance, what resonance in a filter usually does is it emphasizes the frequency at the cutoff frequency. There, see how I brought out that second harmonic? There's the third, the fourth, the fifth, and you can hear it like it's a different tone. And you'll bring out the harmonic series in these things. I crank up the resonance just a little bit more. A really strong filter with a heavy resonance, you can actually pull out each of the individual harmonics and hear them as you sweep the cutoff frequency.
And I guarantee you know that sound. You've heard it before.
So, you guys ever take like a, let me switch to my other screen here. You guys ever take like one of those flexible hose, like the corrugated tube, and you whirl it over your head? You can get it to like, well, that's the harmonic series. And listen, this should remind you of that. Now, I'm being a little pedantic about that. I'm kind of intentionally pausing when I hit that harmonic so you can really hear it sing out. But it really goes to show you what the harmonic content of, in this case, we were looking at a sawtooth wave, right? Square wave has a different set of harmonics. I can show you that.
I can never remember if it's even or odd harmonics. I think it's odd with the square wave, right?
I always have to work it out in my head.
Right.
Russ, when you said you paused when you were doing that, is that sort of equivalent to when you're swinging the thing and it like you get to a certain speed and that's the sweet spot for the effect or something?
Bingo.
Exactly. And I was kind of trying to mimic that with twiddling the knob, right?
Well, it's the resonances that would come out of air going through a tube. So
yeah,
the vibrating string and air going through a tube is the same equation mathematically.
Right.
And so those are the only frequencies that are going to escape from the tube are the harmonic series for that fundamental.
I think it's really interesting when you look at strings, though, because when a string vibrates, there's actually different frequencies of vibrations happening along the length of the string. At the center, it's going to move the widest, and there's your fundamental. And as Pythagorean theory here applies, I believe, as you go down the string, you'll hit other points where the string is vibrating faster the closer you get to the bridge.
No. That's exactly what Fourier says.
Yes.
Each of those string vibration is a sine wave. So you have the fundamental one is the sine of x. The next one is sine of 2x, which is a double sine wave, and then the sine of 3x. And it's sort of how strong each of those vibrations are as they're vibrating that gives that string its tone. Yeah. And why a guitar sounds different than a violin, sounds different than a cello, and all like that.
Right.
That's exactly physically what's going on with the Fourier series.
If you guys are interested, there's a really good book. It may be out of print at this point, but I'm sure you can probably find it on Amazon. There's a guy by the name of Harry F. Olson. And he was involved in the original RCA music synthesizer project. If you, I'm sure, Mike, you're familiar with that, being an MEAP aficionado.
Anyway, just being a nerd.
that helps too. Wait a minute, I know about that. And anyway,
If you're
So
here, you might be a nerd.
Yeah, well, so the RCA music synthesizer was this like enormous room-sized piece of equipment that had oscillators and filters and all that kind of good stuff. And anyway,
your Eurorack made out of vacuum tubes.
Pretty much, yeah. But anyway, Harry F. Olson wrote this book called Music, Physics, and Engineering. And there's a couple of editions of it. In fact, I can go lay my hands on my copy and show you what it looks like. But the reason I bring that up, it's very applicable to synthesis today, even though the book was written, like in the, I think, late 50s. Again, he was working on the RCA music synthesizer at the time. But he approaches this from the standpoint of looking at real musical instruments. And exactly as you're saying, Paul, each instrument has, not only does every instrument have its own sort of spectrum of, well, if I play, an A440 on my violin, I get 440, but I also get this much of, in relation to that A440. If I say that 440 is at, 100%, then I get like, 75% of that is at 880. And, say 63% of that is at, the next harmonic. And I'm not doing math in my head tonight. But
right.
Anyway, so like there's this recipe that says that's a violin.
No, that's the skeleton of a violin.
Right. Because the other part of it is the envelope, which is the attack. And there was some research conducted at the University of Illinois where, interestingly enough, if you took the attack shape of an instrument, say a violin doing a pizzicato or somebody blowing a trumpet or whatever, and you very, very carefully modeled just that attack shape, okay? And you use that to control the volume of a sample of a different instrument, okay? So let's say you took the attack shape of a violin, hitting an arco, okay? But you use that to control a recording of a trumpet, which is a completely different spectrum, right? Which one do you think you identify? Like if nobody told you, okay, all right, I'm going to play you this sound. What instrument is it? Would you say it's a trumpet? Would you say it's a violin? Or you say, I have no idea what that is. It just sounds weird. And the answer is, at least from the research that was conducted, you would identify that as violin. It turns out the attack transient is like one of the most important things that we as humans use to differentiate between different instruments. And then the spectrum, of course, once the note's playing, if somebody's holding out a long note, the spectrum is going to tell you more about what the instrument is than the attack transient, because the attack transient's already over at that point. But if you're just playing like a fast series of notes, that shape of that attack transient is extremely important. Not to sound like an ad for the Hoffman Continuum, but one of the things that makes this instrument really cool, and that's like a topic for another evening. I can show you all kinds of cool stuff about the Hoffman Continuum, but is that tracking that initial attack of your finger hitting the board is something that they paid a tremendous amount of attention to detail to. And I forget what the rate of the update rate is, but I want to say it's like, in the some number of microsecond interval between updates. And the cool thing is, ta-da, if you use this micro CVC module over here, shameless plug, you get to do that with your modular. And, you can do kind of like nice little plucky things if you want, or really just beautiful sort of cello. You
gotta be careful here, dude. You don't have the cable.
I know. I gotta
Get the soldering gun out.
I need to do, and it's not a complicated cable.
Wi-Fi.
Yeah.
So what kind of cable is it? A proprietary cable, or is it what?
It's just,
what is it?
Well, okay, so on this end, on the instrument end,
right,
is just a stereo 3.5 millimeter plug, and then on this end is a three pin DIN. I don't know if you can see that.
Right.
So, and I have all the parts to build it. I just ran out of time to make one before this evening. So that's unfortunate, but perhaps another time. But anyway, yeah, but that's like one of the reasons I wanted to build that module, is to get the ability to do. Well, I'll tell you what. Rather than me controlling the Eurorack, I'll play the Continuum. It's the same idea.
Right.
Just give me a sec.
Oh, you built that module for the Continuum?
Yes. Yeah.
I thought that came with Hoffman.
No. But what happened?
that.
What happened was there's an annual convention called Continuum, where all the Continuum folk get together. And at the first one we were at, I went
Are
there.
they discrete?
I'm sorry.
Are they discrete at Continuum? Never mind.
I'm missing the joke, but that's okay.
It's a math joke. I got into synthesis. Here's how I got into synthesis. I was studying graduate level applied mathematics, and the whole solution of the wave equation and all these mathematical theories apply. Suddenly it struck me as like, oh, that's how a synthesizer works. And that there went a 40-odd year rabbit hole, right?
That was a bit hot.
Do you know what the poles? So when you talk about filters, do you know what the poles are?
Yeah. I mean, I'm an engineer too, right? Yeah.
Okay. Well, for those who don't, when you're doing a filter on a signal, you're performing a complex calculation looking for zeros. And in complex analysis algebra, we know that the zeros come in pairs called poles. So you're looking for zeros of a complex valued function, and those are the poles. So you get 2 poles or 4 poles. And you can't create a brick wall filter. That's, physically, you can draw it out on paper, but physically you can't do that with the functions you're dealing with. So as you bend the shape, you're using poles. You're forcing more equation, but the poles are creating, the effect is you create the resonance, and that's these spikes that happen right where you're bending it. So at the cutoff frequency, the more you bend, the bigger these spikes, and that's the resonance going on. And
you're basically bandpass filtering, but with the more poles you get, the tighter the bandpass filtering is happening.
Yep.
For each.
And that's why you can't have a 3-pole. Well, I guess you can, but it's like 18 dB filters. There's something else going on there.
Yeah.
All right. So
anyway. Sorry.
No worries.
Doctor.
There we go. All right. So everybody seeing here? Hello?
Yes, we do.
Yes.
Okay.
Yes.
Okay.
Couldn't get to the mute button fast enough.
That's okay. That's okay. So, imagine that this is connected to my modular synth, but there's a synth built into the thing, which is designed to perfectly take advantage of all this stuff. But let me see. Okay. There's a level of nuance you can't do with a keyboard, right?
Clipping horribly.
Is it?
Yeah.
I'm not sure where. Sounds good to me. That's interesting.
Unless that sound is meant to be really, really.
No.
Okay.
How's better?
Yeah.
But you see, I can like lean in and out of each note separately. And as far as that whole initial attack transient, now that was a very slow transient, right? But And that level of control ports right over to the modular. So you just you take this X motion versus the, I don't have anything mapped on Y on this particular. You can hear a difference in the, so there's X, in this case X is pitch, Y changes some timbral variation, kind of subtle, and the Z in this case, the pressure into it is volume. But again, you could map those things to, like, I could map X to filter cutoff. In fact, one of the things I did, neat demo, when I used to do a lot of trade shows with my Eurorack stuff, I would map like X to the tuning parameter on my shortwave receiver. So here I am, like, sweeping across here and tuning the radio, So yeah, again, without the cable, I can't really show you that, but that's the general idea.
I think a really excellent and early example of this type of articulation on an electronic instrument is a piece by Olivier Messiaen called Oraison, Oraison. He played an instrument from back, I think it was in the 30s, called the Ondes Martineau, which means waves Martineau. And with your right hand, you could slide. There was a ring that you'd stick your finger in, and a string was attached to either side of the ring, and as you slid up and down, you'd get pitch changes. But there was a block on the left side that you would push in and release to articulate the volume. Yeah, and so it's a really good example of that kind of articulation.
Yeah, and in fact, that particular thing has come back into vogue a little bit. There's a company called Expressive E who make the thing called the Touche, and also the new Arturia Polybrute has a very similar thing built in. Haven't had the chance to play one of those yet, but from what the videos I've seen, they did a pretty good job of it.
Yeah, there's somebody making an Ondes Martineau controller right now. I know Ian Body uses one, and I can't think of the name of it. The French Connection, it's called the French Connection.
Yes. And I don't off the top of my head remember who makes that, but yeah, there's also a couple people making complete Ondes clones. A friend of ours here in Pittsburgh, David Matthews, plays, it's called the Ondea, and it's essentially a modern version of the Ondes Martineau. And it sounds gorgeous, absolutely gorgeous. He's played it at Oscillate for us a few times. Anybody else have any questions for me?
No, this is great. I think it's cool that you build your own modules like that. Yeah. To take your ideas, and like the radio one. I guess I was asking about the antenna, and so I guess for shortwave you don't need much of an antenna.
Well, the longer the better. So I ship these with like a little 5-foot wire antenna just to kind of get you started. Right. And then I also supply, as an add-on option, you can get like a 25-foot wire antenna, which, the best thing to do is like take that, like tape it around the ceiling of your room or something.
Is that like a half wave or a quarter wave? I can't remember. I don't remember the frequency spectrum.
This guy is on 31 meters band, so
it's close to a full wave.
25 feet. No, it's probably more like a quarter.
Oh yeah, you're right. Yeah, really long. Yeah. I always get that confused.
But what I end up doing a lot of times, because I'm also a licensed ham, and so I have some.
I would have guessed.
Yeah, exactly, right. So I have a couple of antennas in the backyard still too, and I'll usually when I'm doing like final QA tests on the RF Nomads, I usually just jack into one of my.
That's where I figured this was leading. Is that the guy who develops this module has definitely got to have an antenna in the backyard.
Oh yeah.
I have some other ham friends of mine. One guy's pretty severe in it. So, do you know a guy named Bob McGuire? I forget, N3 something. I forget, but
that sounds familiar. Yeah.
I just remember in like 1990 when the hams all put together a satellite and sent it up on Ariane. He was one of the guys who got to go down to Guyana and put the payload on.
Oh, how cool!
So I figured, yeah, he's deep in it.
Yeah. Well,
and hasn't lessened, but
right. Well, what's interesting is as as the guy who made the shortwave radio Eurorack module, right? Like I run into all of the people who are both hams and synth nerds. And there's a lot.
It's not an empty set of intersection, I'm sure.
Yeah, there are a few. 'Cause the other thing too is that a voltage controlled shortwave radio is just such a weird off the beaten path kind of module that the people who are really into it make some really fantastic, just out there stuff. It's wonderful. I mean, that's kind of been the whole. The big reward for doing this kind of stuff is the people that I get to meet from doing it. And you all are included in that. I mean, I wouldn't have met all of you people if I hadn't been doing this. And so that's kind of what keeps me going is, just seeing what people do with the modules that I make, running into folks that, are just into electronic music in general. I had no idea before I did this that Pittsburgh has this, when I'm talking to the side of the mic, I want to know if you can hear me.
We can hear you fine.
There you go.
Nice large diaphragm mic, not a problem.
But one of the things I discovered through this process is that Pittsburgh has this tremendous underground experimental music scene. I mean, prior to COVID, 2 or 3 nights a week at minimum, there was something going on somewhere in town that somebody was either doing a noise show or a drone show, live techno sets, whatever, all over town. And it's just been really, really fun to interact with that community and get to know a lot of those folks. Cool. And heck, they've even asked me to perform live once or twice. So,
right.
Too bad for them.
Well, I think having Pittsburgh Modular in your town definitely, you're putting a flag in the ground. So you got to represent and have some scene to have it. But cool.
Yeah.
So I'm a PCV rack guy. I don't do hardware modular. Can I get the software defined radio version of your module?
I've thought about that, and it's like it wouldn't be the same thing. It just really wouldn't. Yeah, I don't know.
You'd have to build some kind of hardware to facilitate that, I would think.
Yeah, unless you connected it to the internet or something and did it that way. But it just wouldn't quite be the same thing. But never say never. Never say never. There are ways to do that.
I like how you have on the modulator how you can use it as a percussion instrument too. Mm-hmm.
Hey, I see an RF Nomad and an AM modulator there behind you.
Over here somewhere.
Yeah. All right.
Yeah. So thanks for getting those kits shipped out to the distributor.
Sure.
They started promoting the heck out of them too that same week, so that was good.
Okay, where'd you get you? Is that from SynthCube?
Yeah.
Yeah. Okay. Good.
Is it surface mount stuff or is it all through hole?
It's all through hole.
Oh,
yeah.
cool.
Yeah. All of the kit stuff is through hole. So did you build the Nomad too?
No, I got the Nomad. I bought the Nomad from you at Neem when there was a Neem.
Oh, that's right. Yep.
Pre-COVID Neem.
Yes.
There will be a meme again this year.
Excellent.
There's also a little A/B switch from our workshop in this picture, right above the.
Oh, there it is.
A modulator.
Yep. That's right.
My worst circuit board drilling in my life that day. Hilarious. Nothing was square. It works great to jump between patches.
That's good. Yeah, all of the kit stuff I offer is always through hole. In fact, you can get the RF Nomad, and the way that's a through hole kit is that all the surface mount stuff comes already soldered, so you just have to put in the pots and jacks and stuff. Yeah. I actually thought about doing a completely through hole version of that, but the board would be almost 3 times as big, So
then you could add an old radio, the old dial that slides.
Yeah.
I want a tube version. I'm kidding.
Yeah. Oh.
Can you get Marine Band in there too?
Just 31.
Well, the interesting thing is the original prototypes I had set for the 20 meter ham band, but it's
yeah.
in terms of, having a better chance of actually receiving a live signal, the 31 meter shortwave band would seem to be the most active, at least around here. I still get customers that are like, I put this thing in, I listen to it all night long for weeks at a time, and I never got a single thing out of it. And, it's just, well, hey, sorry, it's where you live. I can't help that.
You can always build a full wave antenna and put it in your backyard.
Yeah.
So get something then.
But that's why I made the little transmitter kit too, because then you can make your own stuff. The other thing too, and since Scott, since you have an RF Nomad, and if anybody's like thinking about getting one of the other cool things you can do too is take the antenna and like some random. Generally, it's cool if it's like an older piece of electronic gear, like a TRS-80 or a Commodore 64, something like that. Drape the antenna over it. Those
They're
things,
noisy, yeah.
oh, they're so noisy, but they make awesome noises. And
Right.
and you can.
Have you figured out like what games to be running on them to really optimize? Or
Well, that's
That's up to the user.
that's it. You got to create the patches. So gotcha.
Exactly.
That's like your secret sauce patch.
A really good source of noise is one of those plasma balls.
There you go.
Yeah, that probably just has to be in the same room.
Pretty much.
Didn't Jesse Hawley, Modular Moose, use that in one of his sets?
That's absolutely correct. That's
Yeah, I
where,
remember seeing
that's
that.
where I
yeah.
decided that is something that everybody should try. All right, I think we've been on for a good long time now. We
Yeah,
can probably start wrapping things up here.
Sure. So I guess I'll just wrap up with saying I do have a live performance scheduled in May. I really need to decide within the next day or two if that's actually going to happen, because I know Nick kind of wanted to verify that. My life got really crazy here in the last couple of weeks, and I just haven't had any time to rehearse anything. That said, I did a jam back in March. It happened to be my birthday, and I was like, you know what? I'm just gonna do a jam, and I had nothing prepared, and I ended up coming up with a half hour of material. So if folks are into that, I have some stuff I sort of prepared. I could probably kind of fake my way through it. The other option would be, anybody want to take the other half hour of my set? Because I definitely could do that. I'm just throwing that out there in case anybody wants to jump in and split that set.
Maybe. When's the date again?
That's the terrible part. I don't even remember. It's in May.
I have the same exact problem.
Yeah.
I think you're selling yourself short. I bet you could do a full hour of improv. I bet you could.
I could,
especially with the Euro stuff.
You can always jump to violin.
Yeah, I hate to bore people to death, though.
Not at all. Man.
Not this crowd.
Not at all.
Not
all
this
right.
crowd, but
Well,
It's very interesting.
I tell you though, I mean, just get a groove going, and I'll whip up one of my soft synths on the screen here and be jamming along with you. That's what I do.
Is that right? Okay. Yeah. All right. You talked me into it. So, I know one real quick thing, and Mike's gonna laugh, but that's okay.
I laugh a lot.
That's good. So, Mike, I have a massive 5U modular synth system. By the way, I've only been showing you my Eurorack.
Oh yeah.
Yeah, I can show you. Yeah.
So does Mike.
It's absurd. I mean, when I did that performance a few weeks ago, I didn't even use all of it.
All right, there we go.
Hey, that's awesome.
That's
that's awesome.
That's my suitcase 5U. I put that together for the sole reason. See if I can zoom in here. You guys can figure out why I put this together. And
I see .com oscillator. Can't quite fit. Next thing next to it, I should look at my module to cheat. Oh yeah, that's the multi-mode filter. I see that.
Yep.
On the left, is that an envelope generator?
Yeah, the far left's the envelope.
And the far right is not a .com module, unless you change the knobs on it. I don't know what that is.
So, well, the far right is
that's
the
a VCA. Yeah.
Is a VCA. The one to the left of that's the one that has some weird looking knobs on it.
Is that the 5U Nomad?
That's the RF Nomad in 5U.
Yeah, actually, are you still making those?
I don't have any face plates right now. Noise Bug has actually been bugging me to make like a handful
I'm
for
gonna start
them.
bugging you too.
Okay. I mean, the only reason I haven't is because, like, okay, so the ratio of Eurorack to 5U in the RF Nomad is, let me
1
do
to
the math.
1,000.
Not quite that bad, but yeah, it's on that order. I've probably sold at least 300 times more Eurorack than 5U. Yeah. That's, yeah. Not that I don't enjoy making them, but because of the way that I designed it, there's a lot of hand wiring on it, and so they take a little while. And the faceplate, the blank faceplate for that costs me $24.
Oh shit.
Yeah,
Really? You should buy your faceplates from Roger. They're
Well-
a lot cheaper than that.
well, I mean, that's the faceplate with the holes cut and the
Oh, yeah,
the
of course.
logo and stuff on it. So I get this from Metal Photo of Cincinnati, and they do a great job. But yeah, they're a little pricey. So it's like, yeah, if I'm
You're
gonna,
a small run, right?
Yeah, exactly. Economy
Well-
of scale is gone.
yeah, and Metal Photo is like, their policy now is like their minimum order is $400 if you order one or whatever.
Yeah.
But yeah, so I'm trying to do another batch. The nice thing with the 5U size though is there's enough room on the panel. Like, instead of having the little RCA jack for the antenna, it's got you ham guys that are on the call will like this. There's there's a
BNC.
there's a
Oh, it's an
SO239.
F connector. Yeah, I see it now.
Yeah, well, it's a PL259.
Exactly.
Real live coax. So
Sweet.
anyway, that was my closing comment to
For the
the
big boys.
yes. Yeah, you just plug your good old coax right in there.
Cool.
All right, go back to, there we go. All right, folks. I hope that was. Oh, thanks, Mike.
Yep.
It's got my website up there.
Yeah.
Yep, that's me. My Eurorack modules are sold wherever Eurorack modules are sold usually.
That's excellent. Were you at the show that they had in October called, I always have to think about it, Synth Booth?
No, I've not gone to that, and the reason is that the charge to be a vendor at that is very high.
Oh, is that right?
Yeah,
Well, there was several participants who were, because we ended up just having these Zoom meeting after chats, and there was like one or two guys sitting there at the kitchen table soldering away, building their Euro modules or their own design modules. And so I think the maker community and the small community can also be there. But yeah, I guess they had bigger vendors obviously for the.
Yeah, they send me a thing. That's the one. There's a guy named, I think his name's Paolo, who puts those together, because he also does like the guitar pedal expo thing.
Paolo? No, it's a woman.
Maybe
Her husband's a maker. God, my brain is like.
Maybe it's a different show.
They're in Portland. He makes modules in Portland. I forget the brand he makes, and she does these shows like this.
Okay, that's not the one I'm thinking of. The one I'm thinking of, the guy lives in New York, and it's like, they want me to pay $1,500 for a booth. And I'm like, no.
Yeah, you gotta pair up with other makers. That's the way a lot of people get around that. You get 4 people at the same table. You don't need a lot of space.
Yeah, or you go to a different venue that doesn't charge that much.
Well, the thing is,
Like
so
Fest.
I mean, what are they going to as far as venues and stuff? So,
Well, the big one is KnobCon, which is like always the same weekend as NeemFest, which is kind of a pain because I really like NeemFest, and like KnobCon is fun, but it's kind of business for me. So it's like, I'd love to do both, but
yeah, but they don't go to NAMM, right?
Years ago, all the Eurorack guys would get together and rent a single booth together. Okay, and because like a booth at NAMM is like $3,500 for a tiny booth.
Sure.
And so like we would, everybody would rent this, like, well, what would happen is Analog Haven, who's like the big distributor out in Santa Monica, they would rent a booth and like split it with all of the other Eurorack guys. So they just, we'd just pull together. Same thing would happen at in Frankfurt. There's this thing called Music Messe.
Right.
Same idea. It's in Germany. And so Dieter Doepfer, who's the guy who invented Eurorack, Actually, did he do it? No. Andreas Schneider did. The guy who runs Schneider's which is like a really big Eurorack dealership in Berlin. He would do this thing called Super Booth. They like rented this giant space in Music Messe. So it's like corner of Music Messe. There was this exhibit that was all Eurorack. So like the rest of Music Messe was like like you'd expect at NAMM, like guitars and synths and everything else. But they had this thing called Super Booth. Well, it got big enough that he's like, you know what? This is our own event. And so now, like for the last 5 or 6 years at least, maybe it's longer than that, there's just a separate show called Super Booth.
I always wondered where that name came from. Now I understand. That's cool.
Yeah, and that's exactly it. It's just because they used to share a booth at Messe. But Super Booth is awesome. I did get to go 2 or 3 years ago. I was over. So as I mentioned, I do Continuum, which is the Continuum convention. Which most years has been in Asheville, North Carolina, which is a fantastic place. But the one year it was in Paris, and so it was the week before Super Booth. So it's like, all right, if I'm gonna go to Europe, let's make it worth my while. So I did Continuum in Paris the one week, and then the following week I did Super Booth in Berlin. And Super Booth is like, if you're into Eurorack and you ever get the chance to go to Super Booth, go. It's a huge building. They ran out this place called the Fez, which is FEZ, and I can't remember what the German stands for, but it's like literally what it is was like a Soviet youth education camp, like indoctrination center, that once the wall fell, they turned it into this children's education place. And so it's like an indoor, because it has like an indoor swimming pools and there's like playgrounds and all stuff, but the building is this really funky shape. It's like arms that go out in all different directions. So there's all these different halls. It's like the perfect place to hold an electronic music thing, because like everything's kind of separate. So it's like, if you've ever been to like NAMM or any of those shows, it's it's super, 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 super noisy, right? And Super Booth is noisy, but it's like less because like you have like all these individual little crazy warrens and halls and things. And a ton of people show up. They have live performances. There's like really excellent food, and it's a great experience. When COVID is over, I've been saving up a war chest. We're going back, plain and simple. I'm definitely going to do Super Booth when I'm able to do it.
They're doing something this year, right? They're having a limited event kind of thing this year.
I'm trying to think, because I know they put
an announcement at least, but
because it was originally they had it scheduled for May, and they're like, no, that's not going to happen. I think there is something happening in September now.
Yeah, they're shooting for something in the fall, but very distant and
yeah, and the
way pared down and everything. But I think they also will try an online component, and that's what this. So it's hard to keep all these things straight. So Synth Booth is the guys out of Portland, and I mean they were going to be live until COVID hit, and at the last minute they scrambled and set up for all virtual.
I posted the link in chat.
I see it there.
Yeah, for Super Booth. Thanks, Floyd. And I really enjoyed Synth Booth. I'd love to go to Super Booth, but that's not very likely. But
Dutch Modular Fest was another good one that broadcast over the past year.
Mm-hmm.
Wow.
And it had all the typical people that you would think of, like well, they're nearby. It wouldn't take far. It wouldn't be much travel to get to there. So it's like all your Northern European, some UK people.
Well, did you see this concert they're going to have?
Places like that.
Did you see this streaming concert that they're going to have coming up pretty soon? I saw Omri Cohen posted the link, so that's how I saw it. But it's probably like 60 or 70 different, modular performers.
Oh my God!
Oh wow!
Overload.
Over a pretty short time, but just quite an array of performers. I don't know if they're going to do like parallel sessions or what. But,
speaking of that, and if I know we're just kind of dragging this on, but it's fun to talk to you folks.
You too, brother.
Do any of you have Oculus Rift, or I think you have to have Oculus Rift, but the VR headset stuff? I don't know.
I don't.
Yeah,
I have a PlayStation one.
I
Okay.
have a Quest 2, and there's Synth VR on it. A guy out of
There's
Denmark,
that.
Denmark made it. It's pretty good. It's a simple it's a simple modular synth, but you can get a lot of neat sounds out of it. I use it.
That's a
as like
solution looking for a problem, in my humble opinion.
Well, what I was gonna suggest, and like this may work on some of the other VR platforms too. I'm not sure, but Suzanne Ciani filmed a VR concert, and it's awesome because they put the camera, like you are sitting right next to her, and like you can see her tweaking the knobs and making patch changes and stuff like that. It's fantastic. I want to say it's just in like Oculus TV or whatever the standard app is that comes with it. But you know, it's full stereoscopic. Like, I mean, it feels like you're sitting right there. And of course, it's got the whole quadraphonic surround sounds. Like, you know, you can kind of do all that stuff. It's really, really cool.
Wow.
Yeah.
Well, Doug popped in. I know he's a VR guy.
Very, very good.
Gianni is so adorable. I have a great story about her. A few years ago, saw her perform in Philadelphia with her Buchla system, and there was a talk beforehand and then a performance. And in the middle of the performance, she's using that Marf sequencer that she has to come up with this really cool polyrhythmic multi-line sequence, and she starts dancing. I mean, she's like 71 years old, right? But she's dancing like a beast, right? And she suddenly pulls the volume faders down to silence, turns around and looks at the audience and says, "I could listen to this all day," and then promptly turns back around, fades the volume up, and continues on with the second half of the performance. And I just thought, one of us, right?
Yep.
Like,
That's it.
absolutely incredible. If you ever get a chance to see her, she will not perform any other way than in quad. So I highly recommend, if she comes around again, definitely check that out. All right.
Yep. That's all I got, folks.
Russell, thank
Thanks,
you very
Russell.
much for taking the
Thanks,
time to do
Russ.
this.
That was awesome, brother.
And thanks for everybody for joining.
Thank you.
And Gianni, you can stop the recording.